All right, so these are the problems for this assignment, and I'm going to do one or two from each set. Okay, so first one's in exercises 1 through 6, each CK is chosen from the kth subinterval of a regular partition of the indicated interval. All right, this is the indicated interval, and into n subintervals of length delta x. Okay, and then they say express this limit. So this is the limit. Express this limit with this interval as a definite integral. Okay, so just in general for these, the general form for a definite integral will be if you have on an interval from a to b, if you have limit n approaches infinity, summation k equals 1 to n of f of ck delta x. Okay, so that equals the integral from a to b of f of x dx. Okay, so the main things, one thing, you'll always have a dx here. Main thing is just figure out what function you're dealing with and then figure out the limits. And you know, limits will be easy. Limits are just whatever based on the interval that they give you. And the function will be easy too, because it'll be kind of whatever's happening to ck. So like in this one, do number 1. You can see ck is being squared, so the function is x squared. You know, so if your function was x squared and you plug ck into it, you would get ck squared. And then this is from 0 to 2, and our function is x squared, and we just add that little dx. That's it. So that this is expressing that limit with that interval in terms of a definite integral. Okay, for these next ones, they say to evaluate. Okay, there was a theorem in the textbook that said if you take an integral from a to b of a constant, then you'll do the constant times b minus a. That's how you evaluate the integral of a constant. Okay, so for, let's say, number 7, so that integral is going to be the constant integral of 5 dx from -2 to 1, and then you'll do 1 minus -2. And that's 5 times 3, and that's 15. Okay, so just do that for each one, and yeah. Okay, so these say use the graph of the integrand, and so the integrand is the thing that you're taking the integral of. So use the graph of this thing here and areas to evaluate the integral. So remember, when you are evaluating an integral, the meaning of that graphically is the area between the function and the x-axis on this interval. Okay, so I'll do maybe 1 or 2 of these. Okay, so we'll get, here, let's get a graph. Actually, let's get a couple. All right, actually, let's do this. Oops. Okay, so maybe we'll do 13 on one of these. And then maybe we'll do 16. We'll do 15. Okay. All right, 13. So first graph it, and only graph it from -2 to 4. So the way I do it, I'll plug in these endpoints into here to get the endpoints of the interval. So like if you plug in 4 into the function, 4 over 2 is 2, plus 3 is 5. So 4 comma 5 will be a point. Oops. And then if you plug in -2, you get 2. That's a point. And then this is just a straight line like that. And, obviously this keeps going, but we're only looking at it from -2 to 4. All right, and then now we're looking at the area in between this function and the x-axis. So we're looking at all this area here. So we need to find the area of this figure. All right, since this is a trapezoid, we'll look at the bases. That's 2, that's 5, those are the bases. And then the height is really kind of this horizontal distance, which is 6. Okay, so area trapezoid, 1/2 b1 plus b2 times height, 1/2 b1 plus b2 times height. Okay, so the 1/2 and the 6 make 3, so this is really 3 times, and then 2 plus 5 is 7. That's 21. That's it. So this integral up here equals 21. Okay, later on we'll figure out ways to do it algebraically. We won't be doing it graphically for the most part, but right now it's important to understand, and even once we start doing it algebraically, it's important to always kind of keep in mind that one way to interpret this graphically is that it's area between the curve and the x-axis. That's like the main thing to kind of keep in mind, and that'll actually help you solve problems, especially the more difficult ones. Okay, next one, 15. Okay, so this is a circle centered at the origin with a radius of 3. Okay, since it's 9 minus x squared, the equation of a circle, at least the top half of a circle, is square root of r squared minus x squared. So r squared is 9, r is 3. Okay, so just from the origin, it'll just go 3 in every direction. And then we'll just connect these like that. Okay, so we're trying to find the area of this semicircle here. Okay. All right, this is definitely unnecessary. All right, so area of a semicircle is pi r squared divided by 2. Okay, so for this one, r squared, that would be the full circle, so divide by 2 for the semicircle. Okay, and then this radius is 3, so that's pi times 9 over 2. And I'll just write it 9 pi over 2, and that's it. Okay, so 15, if you evaluate this integral, this is 9 pi over 2. That's the answer to that question. Okay, so all these will be kind of similar. You know, some of these will be trapezoids, some of these will be triangles, some of these will be two triangles that you add together. Yeah, so these are all some kind of geometric figure once you graph it that you should be able to find the area of. Okay, this next set, use areas to evaluate the integral. Okay, don't let stuff like, you know, the fact that one of these integrals is a b, don't let that like mess you up, you know. You're going to do the exact same thing that you would do as if b was a number. Okay, so let's get a graph. And that'll help us. Okay, so we're going to find, what this says is this wants us to find all the area from 0 to b, some positive number, from 0 to some positive number. It wants us to find all the area from 0 to some positive number under the function, under the line y equals x. Okay, so we only wanted to find it from 0 to some constant value b, unknown value b. So I'm going to just make b like stop there and say this right here is b. We could put b anywhere, doesn't matter. Okay. And then we realize we're just trying to find the area of this this triangle. Okay, again, don't let it be disorienting. That length is b, and this length is b. And this is a right triangle. All right, so the area, so for 23, the area under this curve is just the area of a triangle. Half base times height. Base and the height are both b. So it's just b squared over 2. That's it. Okay, and this is called an accumulator function because, well, actually not really a function because b is a constant. Never mind. This is just finding the integral where one of the limits is defined as a constant instead of a explicit number. Okay, for these problems it says express the desired quantity as a definite integral and then evaluate the integral using theorem 2. Okay, theorem 2 is just the theorem that shows you how to evaluate integrals of constants. So you can look in the book, look at theorem 2. Okay, find the distance, so 29. It says find the distance traveled by a train moving at 87 miles per hour from 8 a.m. to 11 a.m. Okay, so, you know, after a while you'll get quick at this. You know, so this is going, we're gonna be finding the area from 8 to 11 of 87 dx. You could also, it doesn't have to be from 8 to 11. You could also do integral from 0 to 3 of 87 dx. You know, here I'm using the actual AM times. Here I'm just saying it's from the start and then 3 hours later, you know. the start, we'll call them the start 0, and this is 3 hours later. Either way, you're going to get the same thing. And just keep in mind what this is doing graphically is, whoops. So when you want to find, the distance traveled by a train, so like this will be the velocity, and this will be time. And then let's say this is 87 right here. Call that 87. And then we can say maybe this is 12. So this will be 11. This will be 8. So when they want to find, you see this? So we want to find this area really. Okay, so this is the area from 8 to 11. Okay, and we can see the way we'll find that is by finding this length and timesing it by the height. We know the height is 87, so we'll multiply that by this distance, which is really just 11 minus 8. And that's what Theorem 2 says in the book. So to evaluate this integral from 11 to 8 dx, this is just 87 times, that's the height, and 11 minus 8 is the width. And that's 261. And then units, so we're doing miles per hour times hours, so this will be miles. Okay, and that's how many miles the train traveled. Okay, so you don't have to graph this when you're doing them. I'm just kind of explaining it so that you don't lose track of what the meaning of this is graphically, which is important, I think. Okay, so now these are accumulator functions. Write the accumulator function a of x as a polynomial in x. Okay, so these answers will all be polynomials. Okay, so helpful to graph, I think. We don't always have to, but these we kind of have to. Okay, I'll do 33. Okay, so keep in mind the way you interpret this. So here, this integral is, they want you to find the area under the curve of y equals 3 from 2 to x, some x value. And they tell you that x value has to be greater than 2, greater than or equal to 2, but less than or equal to 5. Okay, so I'm going to plug in, well, not plug in anything, but okay, so this, we can graph y equals 3, this whole function. We only need it from 2 to 5, but I'll just graph the whole thing. And then we're finding the area underneath the curve starting at 2, and then going to at most 5, so x could kind of be any number up until 5, so I'll put x here even though 5's here. Okay, if x is there, then we'd be finding this area. Okay, and overall we're still taking the integral of a constant just because one of these, remember these are called the limits. This is the upper limit, it's the lower limit. And just because one of the limits is a variable doesn't mean anything. So we're still taking the integral of a constant. So you do the constant times the top limit minus the bottom limit. That's it. So this will be 3x minus 6. Okay, so for any value of x that you plug in here, you'll get the area of this rectangle that's formed. Wait, did I make a mistake? Oh, yeah. No, that's right. Okay. Yeah, as long as this will be the value, as long as x is greater than 2, this will work. Okay, and okay, yeah, so I'll let y'all try the other one. Alright, so I gave these. I'm not going to do this in a video. I could, but this says use nint to evaluate the expression. So the first two, 37 and 38, you'll just plug into the calculator exactly like it's written. You know, if you have one of the older calculators, and you know who you are, then you'll have to maybe go on TI-84's website, and it's real easy. Just type in how to type an integral, TI-84 or TI-83 or something, and it'll tell you what buttons to press and how to enter that in with parentheses and commas and stuff like that. Okay, but if you have a newer calculator, you'll type it in, it'll look just like that. Just go math, I think 9, math 8 or 9 will be integrals. And yeah, so you just type these in just like they're written. For 39 and 40, you'll have to create the integral first, and then before you type it in, just from this description. So I'll do 39 then. Find the area enclosed between the x-axis and the graph of that. Y equals 4 minus x squared from x equals negative 2 to x equals 2. Okay, it says from x equals negative 2 to x equals 2, so those will be our limits. And then we want to find the area between the x-axis and the graph of 4 minus x squared. So 4 minus x squared is our function that we'll be taking the integral of, and then we'll always have that dx in there. And then that's it. And then now you just type that into the calculator, and you get whatever you get. So these problems are just practicing typing something into a calculator. Okay, and just remember, for 38, if you're dealing with a trig function, and that's in this class always, mode has to be in radians. So you can see this is in radians also. So okay, so last set of problems. Find the points of discontinuity of the integrand on the interval of integration, and use the area to evaluate the integral. Okay, so it's going to do a couple things. This will be practice graphing stuff that we haven't graphed in a while. And then also, this will be, we haven't talked about it yet, but you can take integrals of functions that are discontinuous. So, if they have a hole or a jump discontinuity, doesn't matter. They can, or an asymptote, we won't find integrals of functions that have asymptotes. That's next year. But really you can take the integral even if the function has a discontinuity to it. Okay, so I don't know if you remember what this graph looks like, x over absolute value of x. So you could think about it, whenever you plug in a positive number, you get 1, and whenever you plug in a negative number, you get 0. So this is always either 1 or 0. So I'll say this is 1 up here. No. I'll say this is 1. And this is, whoops. Yeah, this is 1. This is negative 1. What am I doing? Okay, here. So this, call that 1. Negative 1. So this is 1, 2, 3. This is negative 1, negative 2. Alright, so we want to graph this function. So it's undefined at 0, but 1 for about anything bigger. That's what this function looks like. And then same thing, undefined at -1, but -1 for anything less than 0. Okay. So we can still find area. So just go, we want to find from -2. Here, I'll go start at -2, and we're going to go to 3. So we'll go up until this point of discontinuity and find this area. And then we'll do the same thing, pick it back up with the next discontinuity. Oops. We'll find the area of this other rectangle. So usually when you have points of discontinuity, or at least if it's a jump discontinuity, then you'll have like two different figures a lot of times. If it's a hole, if there's a hole in the graph, you basically just ignore the hole and just find the area under the curve as if the hole was filled in. Alright, so now we can see all we're doing is finding the area of these two rectangles. Okay, the only thing you have to be careful with, okay, so you can see this area is 2. You know, this is 1 times 2, but it's negative since it's below the x-axis. So this area is -2, and then this area up here is +3. And so when we add those two areas, this is -2 plus 3, so this will be 1. Okay. Is that everything? Yeah. Alright, so yeah, so you'll just do, you know, I've done, you know, probably a little less than half the problems, maybe a third of the problems for you. You know, so you just, you know, kind of rewrite the problems that I did, you know, or you know, unless you know, or do them on your own, and then you can check with the video, or, which you've already done since this is the end of the video. Yeah, and then just try the rest. If you have any questions, just email me or do Shobi. Shobi would be better because then, you know, other people might have the same question, and we can answer their question just in one shot. Alright, so yeah, so if you have any questions, just let me know. That goes for the whole week, kind of anytime. Just email me or Shobi. Alright, good luck.